Hi guys, I am going to show you how to get the derivative of sine inverse x with respect to dx. So when you have such a scenario, it's not the same as the derivative of sine x over dx, which we know is cos x. So the difference between these two functions is that this one has been raised to -1, while this one has just been raised to a power of 1. So what we do, we try to return this function into the format of sine x. And how do we do that? We equate our function into y. So y will be equal to sine inverse of x. From there, we multiply both sides with sine to obtain sine y is equals to sine inverse x. So what happens when you have a sine and a sine inverse? They cancel each other. So you get sine y is equals to x. Once you're at this point, you find that your equation is at power 1. So we can go on with implicit differentiation. So we're going to differentiate both sides as with the question itself with respect to dx. And you're going to differentiate also on this side with respect to dx. So we know when to use implicit differentiation. When do we use it? We use it when the factor, what can I call it? We are differentiating with respect to x, but then our function is in terms of y. So that's when we're going to use implicit, but implicit is just basically chain rule. So once you get the derivative of sine y dx will just be cos y dy over dx. This follows this follows from the normal equation, as it usually is, of the derivative of sine u all over dx is the same as cos u du over dx. It's the same thing we've applied, so that we can get the derivative of sine y as cos y dy over dx. From there, we know the derivative dx over dx is 1. So our equation, let me write it just here, will be cos y dy over dx is equals to 1. So we'll divide both sides by cos y, divide by cos y. So our answer, dy dx is equals to 1 all over cos y. But then, our function initially was in terms of x. So we have to return this in terms of x. So what are we going to do? Remember that sine y was equal to x. Since these two will cancel out, sine y was equal to x. So once we draw a right angle triangle and let this angle be y, we know we can use the acronym SOHCAHTOA, which says when we have sine, it's opposite hypotenuse. When we have cosine, it's adjacent hypotenuse. When we have tan, it's opposite adjacent. So when we have sine y, and we know sine y is equal to x, then sine is opposite x, 1. So we are looking for this last part, and we can use Pythagoras theorem since it's a right angle triangle. And you know from Pythagoras theorem that base squared is equals to hypotenuse squared minus height squared. So base itself will be the square root of 1 squared, which is 1, minus x squared. So our base in this case will be the square root of 1 minus x squared. So now when we're looking for cos y, let me just redraw the triangle again. Let's redraw the triangle, I'm sorry. So this was the square root of 1 minus x squared, this was 1, and this was x. So if we want to get cos of y, it's the same as adjacent, which is the square root of 1 minus x squared, all over hypotenuse, which is 1. So cos y is the square root of 1 minus x squared. And remember that we had obtained that dy over dx is equals to 1 over cos y. Therefore, dy over dx is the same as 1 all over the square root of 1 minus x squared. And remember, we had assigned our y to sine inverse of x. So the derivative of let me just write it above here. The derivative of sine inverse x dx is 1 all over the square root 1 minus x squared. I hope you've learned, and if you've learned, then check out cos inverse x, tan inverse x, and check my next video to see if you're correct. Thanks for watching.